Hey guys, I'm here with another exciting video about math. And in this video, we're going to talk about transformations reflecting over a line. Okay, so first we're going to talk about what reflection is. Then we're going to look at a couple of methods for reflecting over a line. If you know how to reflect over an axis, this is a similar idea, but a little bit more difficult. Okay, let's get started. Okay, so what is a reflection? A reflection is a transformation where a mirror image is created over a line. In this case, any type of line. And let's keep in mind when it says mirror image, the shape itself does not change. Okay, let's look at a couple examples here. Okay. So we're going to look at reflecting over the line y equals x. What would be good is if I had a mirror. Hold on a second. Perfect. Okay. So I'm going to use this mirror, and hopefully the camera will pick it up, to see how it's going to reflect over that line. So I'm going to try to move it back and forth, and hopefully you could see it. Okay. So it's going to end up back around here. All right, let me get rid of this. Okay, so now let's take a look how I would do this. You could memorize the rule, which is basically stating that x and y are going to switch. Or you could use the same method you used when you reflect over an axis, which is basically counting the distance. But this is where things get a little tricky. When we reflect over an axis, we're using perpendicular lines and then counting. So I have to make perpendicular lines here. And that's what I'm going to do. So I'm going to make perpendicular lines from the point across the line of reflection. So here's one. Here's one here. And we're going to do the best we can here. And here's another one. And draw these lines way too long. Okay, so now what I can do is I can kind of count the spaces, or if I have handy a ruler, and just use the ruler to get my distance. So like for example, this is about 3 centimeters. So my one point is about here. Here is another one that's about 7 centimeters. So my other point is around here. And my last point is about 9.5. And so he's about there. Okay? And so I have my clone going this way. And there he is. Now remember, and this is important, that the clone is never as good as the original. Now, again, you can memorize these rules, but this method works every time. It is entirely up to you. All right, let's take a look at another one. So this one here is y equals negative x. Notice the downward slope. The rule for that is they flip, x and y flip, and y becomes negative. Another rule to memorize, and if that works for you, then that's what you need to do. Now let's take a look at what this would look like in the mirror. Let me grab that mirror. Hold on, I gotta concentrate. There we go. Okay, so when I turn it, okay, I'm hoping that this is getting picked up in the camera. we could see that it's going to end up around here. Okay? All right. Let me get rid of this mirror. Okay. And let me get my marker. I'm going to draw those perpendicular lines again. All right, with a ruler. Now, myself, I am very terrible at memorizing, but I can remember to apply the same rule to everything. And I think that's why I'm stressing this so much. Is it going to come out necessarily perfect? No, but for anybody who's looking, it should be just close enough. Okay, so now this one here is about 9.5 away. So, 9.5. This here is about 3.5 away. So, 3.5. And this guy is about 7.5 away. So, 7.5. And here's my clone. And you'll see that we got the orientation right each time. Okay, one more example. Alright, so now in this case, look what we went and did. We have a random line here, y equals x plus 4. In this case, right, there is no rule that's going to apply to that. Now, if you have the greatest math teacher ever and he challenges you with this, like myself, right, you're going to have to apply what you know about reflections. I'm going to try the mirror one more time. Let me get it. Okay. And I'm going to place the mirror over it. Again, I'm really kind of hoping that the mirror, this gets picked up. So I'm just going back and forth so you can kind of see it. All right, so now this thing's going to end up fairly close to the line of reflection, if you could see it. It's going to end up fairly close to the line of reflection, and it's going to be oriented in kind of an odd manner. So let me get rid of this mirror. Okay, and the only way I know to do this is drawing those perpendicular lines. So that's what I'm going to do. I'm going to draw a perpendicular line going this way. Again, way too long, but that's okay. I'm going to draw another one. Now, if you know how to use a compass very well, you could do that. You could create perpendicular bisectors, and that will work here. Perpendicular lines. Perpendicular lines to a point would also work. Okay. So now, I'm going to this count. Now, if you want to, I'm using the ruler to be super precise here. But if you want to, you can count the points, okay? I just want to make sure it ends up right for you guys. But if you want to count the blocks, say you don't have access to a ruler, that would be a great way to go about it. So this is about 7 centimeters. Okay, let me get the right color marker. There we go, 7. This is about 1. And that's about 5. All right, and one last time. Here is my clone. Now remember, guys, cloning is very, very dangerous. And it's never quite as good as the original. But this is the reflection over any line. You could draw these perpendicular lines or lines that are creating a right angle across the line of reflection and just count the distance. Count the distance away from the line of reflection, then count away from the line of reflection. Count the distance towards the line of reflection, then count away. However you want to look at it. Okay? I hope you guys found this video helpful.